All right, guys, so today we're going to talk about circles on the coordinate plane and their equations. And you'll see how today's lesson with the equations of circles relates to Friday's lesson on completing the square. So the first thing we want to look at is circles centered at the origin. Their equation is x squared plus y squared equals our radius squared. And if we look at our picture here, if the circle is centered at the origin, we can create a right triangle to show how to find the length or the distance of our radius. So if you notice here, this would just be our horizontal leg and our vertical leg. A squared plus b squared equals c squared, which ends up being the radius. So this is only for when the circle is centered at the origin. If we take a look at circles not centered at the origin, the equation would be x minus the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. And h and k are actually representing the center of our circle. Notice how when we're talking about the center, h and k, however, when we're plugging it into our equation, we have to take the opposite of whatever h and k both are. And then again, equals the radius squared. And we can still use Pythagorean theorem to prove this or derive this. We can see that this horizontal leg, if this point up here on the circle is xy, then this, and the center being hk, we can see this horizontal leg is denoted by x minus h. This vertical leg is denoted by y minus k. A squared plus b squared equals c squared. And notice it is a binomial squared. So keep that in mind. Okay, in our first example, in example A, we're writing the standard equation, which is sometimes referred to as center radius form, because again, it highlights the center and the radius. In this situation in A, we're looking at this circle centered at the origin. We're going to write the equation for that circle, and then we're also going to write the equation for another circle centered at 0, -9 with a radius of 4.2. So for problem A, which is this circle pictured to the left, we can see that the center is at 0, 0. And if we count, we can see that the radius is 3 units long. So since the radius is 3 and it's centered at the origin, we can plug into our standard equation or center radius form. And again, h and k would be 0. So when you plug in 0 for h and 0 for k, that's how we're just getting x squared plus y squared equals r squared, which ends up being x squared plus y squared equals 9. For B, this circle, which is centered at 0, -9 with a radius of 4.2, again, we know the center is 0, -9, and the radius is 4.2. We're going to plug in our center into our standard equation. Be careful when you're plugging in the opposite of -9. So you'll notice we plug in with parentheses to show that those two negatives end up canceling to be a positive. And then you plug in your radius, which is 4.2, and you square that. And this ends up simplifying, to x squared plus the quantity of y plus 9 squared equals 17.64. So that would be our standard equation, also known as center radius form. Okay, in this example, we're given the point -5, 6, which is on the circle, and they tell us the center of the circle is -1, 3. We want to write the equation, the standard equation of the circle. So since we already know the center, all we need now is the radius. And to find the radius, we would need to find the distance between the center point, -1, 3, and the point on the circle, -5, 6. So we're going to use the distance formula to figure out what r is, what our radius is, since we already have the center h and k. So to find r, we're going to find the distance from the center, -1, 3, to the point, -5, 6. And when we plug in, just to jog your memory, the distance formula is the square root of the difference of our x's squared plus the difference of our y's squared. So it might be my alarm from when we're still in school for attendance. Anyway, going back to this. So here you can see the difference of your x's, -5 minus -1 squared, and then the difference of your y's, 6 minus 3 squared. And when we simplify this, you end up getting the quantity or the square root of negative 4 squared plus 3 squared. That gives you 16 plus 16 plus 9, which is 25. The square root of 25 ends up being 5. So now, since we know the center is negative 1, 3, and we know the radius is 5, we can plug this into center radius form, also known as standard equation of a circle. Remember, you're going to plug in the opposites. So if it's negative 1, the opposite of negative 1 here would really be positive 1. The opposite of positive 3 would really be negative 3. And then we would plug in, excuse me, r squared, r, which is 25, and square it, r, which is 5, and then square it to get 25, and simplify. So our standard equation of our circle is the quantity of x plus 1 squared plus the quantity of y minus 3 squared equals 25. Okay, so this problem is actually related to what we did on Friday, which is completing the square. And if what this is saying is the equation of the circle is x squared plus y squared minus 8x plus 4y minus 16 equals 0. We want to find the center and the radius. In other words, we need to put this in standard form or center radius form, and then we want to graph the circle. So to remind you, we want to take this equation and we want it to look like this. So we're trying to take that equation and turn it into this, which is going to require us to complete the square twice. So let's go back to our example. And let's take a look. So first, in order to figure out the center and radius of our circle, we need to write this in standard form. And that means that we need to complete the squares with our x terms and our y terms. Because remember, we want two binomials squared. So to do this, we'll get to that little note in a minute, but to do this, right, we have to take the equation we're given and we need to clean it up. We need to organize our x terms together, our y terms together, and move our constant to the other side. So when we do that, you should end up getting x squared minus 8x plus y squared plus 4y equals 16. Now, when we complete the square, what we're trying to do is we're trying to create a perfect square trinomial with our x's and our y's, so we can rewrite it as a binomial squared. And this is just a little hint for you. When we complete the square, what we're adding is half of b and squaring it. So in other words, in this case, b is negative 8. When we take half of negative 8, we get negative 4. And when we square that, we get 16. So x squared minus 8x plus 16 would end up giving us a perfect square trinomial, which we can then factor into a binomial squared. Now we need to do the same thing with our y's. So we're going to take our b term, which is negative 4. We're going to divide it by, positive 4, divide it by 2 and get 2, and then square it and you get 4. So we need to add 4 to y squared plus 4y to create a perfect square trinomial with our y terms. And whatever we add to one side, 16 and 4, we need to also add to the other to keep our equation balanced. So when we factor and simplify, we end up getting the quantity of x minus 4 squared plus the quantity of y plus 2 squared equals our constant, which is 36. So now from here, I can identify what my center and my radius is. So the next step, it really isn't necessary. We know we're going to take the opposite of 4 and the opposite of positive 2. It's just rewriting it that way for you. So the opposite of 4, negative 4 is positive 4. The opposite of positive 2 is negative 2. And our radius, the square root of 36, is 6. So we end up getting that the center is 4, negative 2, and the radius is 6. And if you were graphing by hand, you would need graph paper. However, when you're graphing on today's practice, the graph will show up on the computer and you can plot your point and kind of graph it on the computer that way. Now, when I'm graphing by paper, just so you know, I like to, obviously we need to graph the center point first. I do want to point out that this graph is counting by twos. And then the next thing we want to do is plot our radius so that we can draw our circle. So if we're counting by twos, I'm going to go up 2, 4, 6, right 2, 4, 6, down 2, 4, 6, and left 2, 4, 6 from my center. What that does is it plots 4 points on my circle, and if you're doing this by hand, it makes it slightly easier to draw your circle the more points you have. So I always plot points from my center above, right, below, and to the left. Okay, so here they're telling us to prove or disprove that the point root 2 lies on the circle centered at the origin and containing the point 2, 0. So because of the language here, this leads me to believe that we need to be a little bit more formal. Since it says it's saying it's to prove it, it's not really a traditional 2-column proof. But because we're given some coordinates, I'm looking at more of like a coordinate proof. So if I know my circle is centered at the origin and it has the point 2, 0 on it, if I visualize my coordinate plane, my center's at the origin and then I went right 2, up 0, that means that my radius is 2 units long. And I can talk that out and kind of like think through that logically. However, but because of the language here of prove, we want to use the distance formula to prove that. And this is just a modified version of the distance formula. We know x is representing, h is representing the x variable, k represents the y variable in our center, r is that distance. So when you plug in to the distance formula, we end up getting that the radius is 2, which we kind of just talked out loud, kind of thinking about the circle and plotting it on the coordinate plane hypothetically. So now this circle is centered at the origin. It has a radius of 2. We want to know if root 2 lies on that circle. So what we need to do is we need to take the point root 2 and the origin 0, 0, and we need to find the distance between those 2 points to figure out, is it in fact a radius of 2? And when we plug into the distance formula, we end up getting that it does have a radius of 2. Therefore, root 2 lies on the circle centered at the origin containing the point 2, 0. If we were to plug in root 2 and we got a number other than 2 as the radius, then that would mean that that point, root 2, does not lie on that circle. So if the radii are equidistant or equal in length rather, or congruent, then that means that those points all live on the same circle. But if you get 2 different measures for the radii, then that would mean that that point given is not on the circle. Okay, and then this is our last problem. It's a real world problem about an earthquake. It says the epicenter of an earthquake is the point on the Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of the earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. So it says use the seismograph readings from locations A, B, and C to find the epicenter of an earthquake. So they're giving us information about the epicenter from point A, from point B, and from point C. So we can take those 3 pieces of information, right? Seismographs are needed in 3 different places to locate the earthquake's epicenter. So if these seismographs readings create circles, right? If you think about it, circle A centered at -2, 2.5 with a radius of 7, circle B centered at 4, 6 with a radius of 4, and circle C centered at 3, -2.5 with a radius of 5. So if we plot those 3 circles, we can find a location that lives on all 3 circles, or a point that all 3 circles share in common, an intersection point between the 3 circles, to figure out where the epicenter of this earthquake actually exists. So let's go ahead. Keep in mind, I want you to notice that we're counting by twos here. So we're going to graph circle A with a center at -2, 2.5 and a radius of 7. Circle B with a center at 4, 6 and a radius of 4. And circle C with a center at 3, -2.5 with a radius of 5. And I'm seeing that all three of these points look like they intersect here. And again, we're counting by twos. It looks like it's approximately 5, 2. So we can say the epicenter of this earthquake is approximately at 5, 2. Okay, that concludes today's notes. You want to go online and finish or try the few practice problems for today, 10-1, 10-7, day 1, and then tomorrow as well, 10-7, day 2. If you have any questions, reach out to your geometry teacher.